Hello, this is my video on how to access binary structures. In general, we have 5 types of information. First type is informational. These are the things that represent reality. Person's name, his age, school he went to, his wife's name. These are the things we generally keep in a database. Then we have derived values. Age, which is derived from informational values of date of birth. Some duration. 20 years is a duration. And then we have declarations. These are the values that tell us about the value. So it's a 4-byte value. It has a name. These are the names we have to access it internally or externally. And anything else that we need to declare. And then we have qualifiers, and so we can qualify some of these as being read-only or things that help us humans better understanding the classification of this informational value. And then finally we have logic. And these are values that how something is done is informational. So we need logic as part of our information structure. I'm going to give you a brief explanation before the demo of what we're going to try and accomplish. This is our current software technology. So every application looks like this. It's basically, we put the informational, declaration, qualifiers, and derived values in our source code. And then below that we have the logic. And that logic has all kinds of subsystems, which is our formatting logic. How do we format this integer or this floating point value? And how do we do I/O? How do we get the values in and out? How do we get them into and out of memory? And we have vendor logic and information. And then we have derived value logic. So we have all these things that are generally hard-coded into our applications. And then our applications will read and write from files or databases to get some informational values to work on. And so this is our current application. What we want to do is we want to be able to segregate this so that we can be shareable. In our current technology, we have one application and one data structure. And that application can only read that one data structure, and only that one application can ever read it. Well, here we want to do something a little bit different. We want every application only to be concerned with the logic. And we want to externalize the knowledge that it works on. If you put it in the source code, it is locked to that particular logic. And what happens is the logic now is only concerned with that one data structure. We do this, what we do is we externalize all this so that we can read in our complete knowledge from anywhere, from about every file, every computer, every hardware device could externalize their information. And forms are another source of information. Our scripts, our programming scripts, our languages, our spoken languages and our computer languages, our documents and our databases. All of this information, which really has nothing to do with the logic, could be our knowledge structure. And then to further remove things out of our source code, we can put logic on demand part of the compiler, so that we can supply the formatting logic, the I/O logic, the moving values in and out of memory, and the vendor-specific logic. So with, let's say, Oracle or SQL Server or client-server technologies that we already know that logic, we could supply that. And then we have term-based logic, which is access to all the videos and graphics and hardware, compilers, accounting systems, and hospital systems. And they can all be done by externalizing all of this information from Find the Cat in the Picture. And so what we want to look at is how to separate knowledge from logic. And that's what we're going to demonstrate. So let's start the demo. Okay, this is the demo of access to binary structures. I've also added some other formats that are scripted, like JavaScript and COBOL. C++, and so on. And so I want to demonstrate access to information, no matter in what format it is. So if it's in binary, we go get it. If it's in text format or in PDF or whatever format it's in, we need access to it. It's your information, you need access to it. So that's what I'm looking at. But before I start on the demo itself, I'm going to kind of describe the final approach of what we're trying to accomplish. So we have executables, and what I want to do is I want to add information to it. So I want a detailed header that we can put information in that's useful for this particular file. We want to put in the data structure that this file is actually in. So right now, all of these files that we are looking at have one application that knows how to read and write these files, and we want to open that up so that anybody can load these files for the values that are in there. So we have the regular layouts and the lookup tables. We have the load program, and the load program is in there because everything changes. Okay. I want a program for the future. The future is this file is 10 years old. I need to load it. And if the load program is changed, or it's on a, it's no longer being used, or lost, or whatever, well, I'm going to put all that information in the file itself. And this is going to be partitioned so that the original exe is still there. There's nothing changed to it. We're just adding to and put it in a cell structure. And the cell structure is unique in that these are partitioned, so we can access just the header if we need to, or just the data structure, or just the load program, and so on. And so we'll be looking at that. And the reason we do this is so that we can always, there is no incompatibility in any file that we have on our system. And so the J in the system I'm writing, this will all be done for you. You will not have to do this. It will be transparent. And by doing this, we no longer have file I/O. It's done for us because this information has already been done for us for every file. So, and so all the information is, if it looks like a table or if it has graphics, it can still be used for display purposes or editing or whatever we want to accomplish. So this is where we're going. We'll look at now some of the details here. So here I've taken it and used the control script to build these tables and these outputs. And so this is the executable assembler.exe that is in a proprietary format. And so what I did is I took in and went to the documentation, typed this in, and these are all the records. So this is the first record in that file, and these are the names that were in the documentation. I did not change them, then pick better ones. I just left it for what it is. And so I just simply typed in. It took me about a day to type this in. Is it all correct? Well, I have no way of knowing. I mean, without a lot of work, because I did not write this. But in the long run, all of this will be done for us by the compiler, because it needs to be able to read and write these files over and over again by any application on any operating system, by any hardware device. And so these files, and so we will look at, and this file just for this is 600 lines, but it has some code in here because date has to be calculated very specifically. It's this particular date. Not all of them are identical. And over time, this changes. The date changes. It's obnoxious how much effort we have to go through and how many things are breaking over time. So that's why I want to put all this information in the file so that that date can be decoded. Actually, date is really a bad concept in our computers. It's a duration. It's a duration from some date. Durations, it's like age. No, we need to get out, and I'd like to go to a Julian date where we have the day of the year from 1 to 365 or whatever, and the year, and then the time is separate. But we went and used our stupid clock, and that's killed us more times than not. And then we have 180 different formats for dates when we type it in. Is it year, month, day, or day, month, year? And do we use commas or periods? And God, it's every country has a different format. So I think HP calculated there's about 180 different formats that they've come across. So as you see, it's not an easy issue. Okay, so let's so we can look at this, and these files give us all the information, at least that I was able to type in, and I put in the lookup table so I can decode what these bit settings are, and it says it's an executable file, and it's a 32-bit machine, and that it's a Intel 386 instruction set, and then it was created on this date. I'm in Central Time Zone, so I convert it to my time. And then we have tables in here. Executables have imports, and so it references these three DLLs. DLLs are dynamic link libraries, which are basically subroutines that are stored in other files. And this particular program called 6 or 8 subroutines in my little assembler executable. I call these routines. And then out of this file, I called 4 routines. But some of them are up to these numbers. Basically, this one routine, this one DLL probably has maybe 1,000 exported subroutine names. Those names that the user needs. There's probably 10 to 1 internal subroutines, and only 1/10 of those get exported. So here we're looking at 500 that are shown. Could be 1,000 exported and 10,000 internal ones. So what this tells me is that our executables were designed 40 or 50 years ago, probably 60. I mean, just because DOS didn't come out to 84 doesn't mean that, or whatever it was. I had DOS 1.0, and so I've gone through all of their versions forever. But what it tells me is that it's loading all of these DLLs. Now we can take a look at one of those DLLs, which is that GDI 32. So that's this last one here, and it's loading 5 functions. But if we look at that DLL, and here we have exports, which is this file, and these are all the subroutines that it exports for anyone that wants to use them. Okay, and if I took one of these names, I should do this, but I'm not going to. But if you took one of these names, you went to the documentation, Microsoft had documented all these exported function names and how you call them and everything, and that information isn't here. It's in documentation. It really needs to be in here so that we can get rid of documentation. That's what I'm after. Anyway, so that's why it's important to know that if I look at this and everything's separated like this, this is why your applications take forever to load. Some of them take 5 or 10 seconds to load. Why doesn't it just come up? Well, basically because they have to load all these DLLs and then map all these subroutines to the memory addresses and do all this work, when if we just pulled them out, put them in the executable to begin with, then things would load instantaneously, or dang near. Yeah, I think it would be pretty much instantaneous because we could do memory mapping and things like that. I mean, there's a lot that from the technical side I could do, but I can't do it in this technology that was written 40 or 50 years ago when we had no disk space, and it really made sense to do this. I don't think it makes sense anymore. Since our disk space is cheap, our time is not. And so we're wasting a lot of time by using the poor technologies, in my sense. I'm pure technical. I only write programs. I don't run them. I don't try and use them. I don't really, when I write my compiler, it's all me. Everything I wrote I don't use any of these applications. I don't use any other compilers. I don't use anything that is of no value to me. It doesn't make any sense to try to figure out what somebody else did. Like, would I use these executable formats? No, absolutely not. Basically, for one, you don't own these DLLs, or so they say. To me, it's a funny thing. They're on here. Could I use them for my application? Yes, probably, maybe. I don't know. Copyrights, and they change them, and know who reads them. I'm not going to read them. Anyway, so these are the two technologies that exist out there. Here's font libraries. This thing is a joke. It's really written not to be used by anybody but Microsoft or Apple. I mean, somebody really went out there and encrypted their fonts, and they made it an application. So it's these codes. If I look at the script here, I had to decode the instruction set. So it coded, so it's kind of like a programming code. So they went to court and got copyrights on this because fonts are a program, not data. If it were data, we could use it. So I'm going to go to a data structured font that I can actually use. Our fonts are so bad, I can't use them for any of my editing capabilities that I want to produce. I want to be able to do mathematics in 3 dimensions, 2 dimensions. Right now, all of our fonts are 1 dimension, and it's really, really bad. I cannot do what I want to do. Anyway, so it has weight factor tables and things like that in here, which is, doesn't really do me any good. I don't want to use these fonts. I'm going to use my own. So we have dBase files, which we can have, and these are the tables and the structure. So these are the rows, and then these are the columns, and then we can visualize that and take those, pump them in, and say, here's a grid. Go ahead and put it into a table format. And so really what I'm doing is coming up with ways to create my namespace. How can I get to all this information on every computer across the universe and do this? This is what I'm after. And so I'm going to get rid of client-server technology, get rid of files, folders, databases, and so on. So if I look comma separated values, it's kind of the same thing. But in my namespace, I want to add a SQL statement. So I can just treat this as a table. It is a table. I might as well be able to do joins to it and, whatever else. SQL is everybody knows it, or at least I know it. I guess there's quite a few people that know it. But we could use any format we want. I mean, we could do anything we want to. We create new technologies. And that's what I'm saying. We have to move forward to be able to create new technologies and not be stuck in 80-year-old executable link library fonts that are locked up so tight that it's ridiculous. We need to be able to create our own fonts, which means that we have all kinds of physics technologies, mathematics technologies that need to be improved, and we can't do that without better display capabilities, and which is our language. You know, for me, why do we have a C and a K if they can be interchanged in some spellings? Anyway, there's a lot of things I don't understand, but we live in the world and we have to follow it. And here's HTML, so we should be able to go into HTML and pull out our scripts and the links, and here's one link in there, and the values and the styles. I didn't break these down, but I could have, and so styles and the body, and I didn't really go through those too much, but anyway, so basically create a DOM for you. I'll do that a lot more efficiently, but you can't get anywhere in writing your own browser without building your own DOM, and that is that is very specific. I hate to tell you this, but because it's nested, which is nobody can really do that. You miss a tag, and it depends on how the application is written. So we have Chromium. It does things independent of what anybody else would do in a particular case. And that's why it doesn't really work. We have to be able to rely on what we say, and that's what we're trying to accomplish. And here's a flexible image transport system, which was a NASA, basically international star telescopes and things that want to put out this information. And they created this little format. It has a, this is a standard format you're going to use. Well, nobody uses it. It's all different. And here we have basically 161 fields. We don't know what they are. They're limited to 8 characters in their field names in this particular format. And a lot of these, there's probably 5 different tables in here, but they only allow just a list of names and values. So it doesn't really help us because we don't know what these values are really useful. We can make guesses, of course, but what exactly are these? This is not my profession, so I've never heard them, but that's what we got to get to. We got to get to knowledge transfer, not just value transfer. And unfortunately, we can't even do value transfers. So I want to get the values transferred, but I do want to give people the capability to really, really put knowledge in their system so that everybody who sees this knows exactly what's going on. So there's no more misunderstandings of what the capabilities of any of these formats are. And here's JavaScript. And we can split this up. So this is the JavaScript. And what I said is I split it up and said that the first line is a string. I call it string. I won't call it text. String is something I type packages with. Text is something I type in. So string, whoever created that, Fortran 77 started that, I think. And so I hate the word string. Anyway, programmers, who can trust them? So here in line 3 is test ball, open paren, close paren. And so I tag them with what type they are, and then, and then so on. And so here's line 8, which is function, test ball, it's function ID. So this is format. And so this can be taken to the compiler part of it and taken directly into it. But we could use it and say, look, give me all the function names. So we could look for function ID in all of this. So anytime we see function, wherever function is, let's see, line 39, okay, here's a function ball dollar. And I could go through this list, which is just, which is just a tree also. I won't get into what that is. But anyway, you could just then have access to all the functions and pull those codes out. So what we're looking at is being able to create an SQL here to do that for us, which is really what we're after, is not relying on programmers to do the things that you should be able to do at your desk without knowing anything about programming. You shouldn't have to do that. All this stuff, there's very little logic that's actually done. Okay, so in this one, here's fibs, okay. I did the program here, and basically this draws the image. So it's basically a row column grid, and then I calculate, the index into just an array of bytes. Basically, if it's 10 columns, then first 10 bytes are actually 4 bytes. Each 4-byte value there's 10 of them, and that's row 1. And then the 11th through 20 is row 2, and so on. So we calculate. And that's this whole 25-line program will draw any grid, any image from any video, or, we don't need there's not a lot of code here. And there's nothing secret about this, but we'll give it away. And when we look at all these applications, they're identical. None of them do anything different. And we don't need to really see it. But I want to give the capability. You say, look, you just drew a picture. Let me see the code, how you did that. That's what I want to get to. That's why I want to get to the source code, so that we can pull out just those things. How was paychecks calculated? Let me see the code that actually did that. That's where we got to get to. And then we can go in and do analysis of how many times this value was changed, and so on, and where was it. Let me see the code that created it. Let me see the code that actually modified this. Let me see the history of it and what values. We could do 1 billion times more programming with a namespace without actually programming, and do those types of things, and say log it and keep track of it, and who changed it, and and so on and so on. So all this knowledge that's out there, what we want to do is really get it out of our human head and get it captured, so that no human ever has to remember anything. So if I'm a programmer, I'm writing this, it's not up to me. 90% of our applications are still in the programmer's head. Why did you pick that algorithm? Why did you do this? And there's a million reasons. It's like I like to use the example of going in somebody's kitchen and trying to find the forks. There's 3 drawers. What's the chance you're going to find it? 1 in 3. Not really very good. And that's just forks. So we know it's in the top drawer. We know certain things about that, but but when we have billions of facts and values and reasons for those values, why should it be changed? Who can change it? What is that really a value? Should this 255 be really 256? And so on and so on. I mean, why did I pick 255? Why didn't I pick 256? And so on and so on. And And these things it's in my head. Yes, I know why I did it. But you looking at this, you don't know. Now, why did I put 120 here? That's the problem with programming. You don't know why those values were here. You can make assumptions. I just arbitrarily picked it. It's transparency. Why did I pick 120? I have no reason. I just did it. The image came out is all I really cared about. Anyway. So, all right. So, and then compilers. Here's our pictures we have in this particular file. We had 2 pictures, and I'd like to select out rows 20 through 50 and columns 50 through 98 and draw those. So, I want to go in and view. And so, however, and there again, I'm doing this as an example. How my namespace is I may come up with a cleaner, easier way, but just putting numbers out there without, putting the rows and columns doesn't make any sense. And so, anyway, there's a whole lot of knowledge transfer that we need to get to the users so that they don't have to make guesses or go look at documentation. I want to get rid of documentation, and that way we can move forward in all of our technologies. So mathematics, physics, chemistry. So we want to be able to put in chemistry symbols and equations, and they have some really nice equations. I was impressed the way chemistry works, and they've done. I'm really impressed with that whole technology and how it was designed. Anyway, and then we have JavaScript, like I said, and COBOL. So COBOL is the same kind of thing. And so here, if we wanted to go get the functions, like I said, we put that in the namespace, and we use these parsing algorithms to find just the function. We call them functions here. COBOL can have functions. Okay, I've used them. Not too many people have, but there are functions out there. And there's also procedures. And anyway, I won't get into that, but that's, anyway, so if I wanted, this should be a procedure, should be B. Anyway, so that's what I'm after. And then we have MATLAB, which is some program out there that does mathematics. I want to put all this in. The compiler I'm writing will accept all these languages because they're all the same. They just simply do, this just calls a subroutine. That's all it's doing. It's the same way as JavaScript. JavaScript calls a subroutine somewhere. Here, right, document right. It called a subroutine. It's doing the same identical thing. Okay. And then we have DOS batch programs, which is, again, just another scripting language. And we want to be able to put all of these. We want one language. We don't want to have 15 different compilers, 15 different environments. So if you have COBOL programs and you want to compile them, fine. If you have the DLLs, we can attach all the functions that are being called, all the procedures and all, so it's not like we're losing anything. And it really changes nothing, except that software development, instead of taking man years to do, we can do in minutes. So if you want flight control systems for an airplane, Grumman, who makes those subsystems for flight control systems, says there's only, 483 subsystems in any aircraft. And they're all, it's a fuel system. It pumps fuel. Transfer systems. Transfer the fuel from one system to another. Fuel gauges, airspeeds, and all these other things are just simply values. Again, the same concept. computers only work in numbers, and so that's what we do. Anyway, that's the concepts of moving forward, which is these I'm using as my demonstration here as where we want to go, but the real tool here will be the namespace, which is what I'll be working on this month. And hopefully by the end of this month, November 2024, I should have the namespace and the compiler working. I have a compiler, and I took JavaScript and I extended it. I put like 800 changes to JavaScript, namespaces, partitions, just things, flow control. Oh God, our flow control is terrible in all of our languages. I was up one night with Compaq when they were writing a Fortran compiler, and I was trying to get their error trapping working. 4 in the morning, I yelled at them bad. Yeah, I was working with them to fix their compiler because it wouldn't compile my program, brand new. So I gave them about 50 changes to their technology, to their compiler. Anyway, I finally got down to the last issue, which was it wouldn't interrupt on a divide by zero. I couldn't catch it, and they kept saying, I was talking to Mike or whoever, and he said Bob over there was doing that part, and he said it was working. And 4 in the morning, I couldn't get it to work. I spent 2 days on it. I couldn't get it to work. So anyway, what we should look at is the namespace, which is how do we access this information. We want to be able to access the world of information, every machine out there, your refrigerator, if it's got a computer on it and it's networked, Rachel's phone, my wife's phone. If I want to send a picture, I can just say send this over to her phone. We want to get rid of client server technology so that all the machines are communicating effortlessly, have absolute control over whatever it needs to have access to. And security is key, of course, but I want security at the hardware level and at the software level. Absolute security, not this it can't be done. Well, I think it can be done, and that's what I'm going after. We rewrite the hardware. We move forward in our hardware technology, which we haven't moved forward in. None of our technologies have moved forward since day one. From 1776, it's still the same technology. And we still have the same instruction sets, which is ridiculous. And our fixed length binary numbering systems is terrible. That's what my life has been, is dealing with all these issues that don't work. So I'm trying to fix them. I'm going to fix them and at least determine that it can be done. All right, well, thank you. This is the demonstration of how to access binary structures. I will get this sample out there on the internet, hopefully in a week or two. And this is all proprietary right now, but I'll give and let you see this same information and play with it. It won't be dynamic, it'll be static, but at least it will give you an idea of what's going on. Thank you for your time. Bye now.